All right, guys, welcome to the final and sixth video. I think we're up now. Sixth video, in terms of our main notes, not in terms of examples, that we'll be covering, which is on the composition transformation or composite transformations. So, what exactly is a composition transformation? Well, or at least a composite transformation. A composite transformation. Okay. A composite transformation. Okay, composite transformation is when two or more transformations are performed on a figure called a preimage to produce a new figure called an image. Okay, and we already know that's what those are called. So what exactly does that entail? Well, it means you're doing two steps in one transformation. That's basically what it's saying in a nutshell. So let's take a look at a quick example. All right, let's say, for example, I had 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Let's say I had coordinate plane, as we can see here. And I was told that I need to take an image, okay? And since we're dealing with 3 now, I'm going to break out a third light color, probably pink or either light green. I don't know which yet, but we'll need a third color. Probably pink because I want to keep another shade in the reds. Pink is lightish red. I don't know if anybody gets that reference. Anywho, so let's go ahead and start off. So let's say that I have a triangle that starts at 2, 1, 5, 2, and 4, 4. So over 2, up 1, 1, 2, 3, 4, 5, up 2, and then over 4, up 4. 1, 2, 3, 4, 1, 2, 3, 4. So, okay, here's A, B, and C. All right, simple enough. Nothing too crazy, okay? Connect my points together. Okay. And so what you'll need to do is you will need to have your pre-image, your image 1. I use Roman numerals. If you don't, that's perfectly fine. And then, of course, your image 2. Okay. And the rule for this guy, or at least what we're going for, is the following. Okay. We are going to, or at least what it's asking for, is we're going to rotate 270 degrees, okay, and I'm not stating obviously after the fact, so this is counterclockwise, and reflect over the y equals negative x, okay? Which means that effectively my rule for this okay, is going to be first xy becomes y negative x, and for and sign, and xy becomes yx. Okay, so remember we have a negative value for a reflection. I'm trying to go back and look real quick just to make sure. And we make the for negative x, and we make them both negative. Okay, so those are my two rules, right? Now I do apologize, I'm kind of cramming this all in here because I need the second half of the page. This is going to be a tighter section of notes because I need to get essentially everything onto this one page, and then I want to use the other side for examples, or at least a specific example that talks about the order of these things. So let's go ahead and continue onward. So we have A is going to be 2, 1. B is going to be 1, 2, 3, 4, 5, 5, 2. And C is going to be 4, 4. Okay? A prime, B prime, C prime, right? A prime, first one, is going to be 1, negative 2, and then 2, negative 5. And then C is going to be 4, negative 4. Okay? For image 2, A double prime, B double prime, and C double prime, A is going to be negative 2, 1. B is going to be negative 5, 2. And C will be negative 4, 4. Now, notice that these are the order here was done in the sense that I did my rotation first and then my reflection, which is totally fine, all things considered. Okay? So if we do that, right, and we do have essentially our rule for 270 degrees being y negative x, everything checks out. So let's go ahead and start plotting this guy. So we're going to go over 1, down 2. We're going to go over 2, down 5, 1, 2, 3, 4, 5. Then we're going to go over 4, 1, 2, 3, 4, down 4, 1, 2, 3, 4. Okay? Okay, there's B prime, A prime, and C prime. So far, so good, right? We have a right angle that forms, which means that we did rotate successfully 270 degrees the other way. Again, if I need to show that, I can. So we've got our right angle that forms right here. So my angle around was indeed 270 degrees, right? So we went around, and that was indeed 270 degrees. So we are good there. All right, and then of course we're going to reflect over the y equals negative x axis. Whoops, sorry, I'm kind of losing. All right, which means that we're going to go, oh, I meant to say positive. I'm sorry, so that should be positive x axis. That is my fault. So small typo, and these should be positive values. I do apologize. So I'll probably just rewrite that. Sorry. Let me fix that. So that'll be yx. Okay. There we go. So that's what we're reflecting over. Okay, so we're going to reflect over that axis, which means that our other green line We're going to reflect over that. So then our final coordinate points, our final resting place for this shape will be over 2, up 1, over 5, 1, 2, 3, 4, 5, up 2, up over 4, 1, 2, wait, 1, 2, 3, 4, up 4, 1, 2, 3, 4. Okay. All right. A double prime, B double prime, and C double prime. And there we go. There's our final shape. So just to give you guys an idea of what we're dealing with here, that is a full set of rotations. So why did we do all that? Well, the reason why we do that is because then we're able to do more than one translation in a step. Okay, keep in mind that the order does matter here. In class, I will here in a little bit we'll do an example that specifically shows why that is the case. But I do want to add a star down here in red. Does matter. If we were to do the rotation second and reflection first, we would end up in a different final orientation. Okay? So, and actually let's use this example to display that. So let's say, for all intents and purposes, okay, that I did decide to do the other way around, right? So I'll do it on this side this time around, okay? So if I graph this guy again, okay, 1, 2, 3, 4, 5, 5, 6, 1, 2, 3, 4, 5. X, Y, there we go. Okay, so let's say that I did do this in a different order. Let's say that in an alternative universe, okay, I stated that I wanted to then instead rotate. So maybe not rotate. I want to reflect over the y equals x, line y equals x, and rotate 270 degrees. Okay, so let's say in an alternate universe, I wanted to do it the other way around. That I want to do. Sorry, my headset turned off on me again for the upteenth millionth time. So let's say that I want to do it the other way around, right? Okay. So hopefully I'm still receiving. I don't know why my headset turned off, but it's been doing that recently. So I want to do it the other way around. Okay. And if I do it the other way around, okay, so I'm still going to have the same starting shape, right? Over 2, up 1. I'm still going to be at 5, 2. 1, 2, 3, 4, 5, up 2. And we're still at 4, 4. 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, right? There we go. So we're still going to be at the same spot, okay? There we go. So we've got C, B, and A, okay? So there we go. And we know that our rule, right, that our lovely rule, I'm going to put it down here because I need the space. So xy is going to become, first, it's going to be the flip, which is going to give me yx. Okay? And then in terms of orientation, that then becomes a new xy points. So if you notice in the previous one, we did flip this back when we did it. This isn't like going to continue onward to another situation, because if that's the case, then it wouldn't change. You need to take a break in between. So ampersand, okay? And then state the rotation, which would be yx becomes y negative x, right? Rotation 270 degrees. Yep. Okay. So check it. All right. So from there, we then we're going to rotate this guy around. So, or not rotate. Sorry, we're going to reflect him around. So here's the thing: since we're reflecting him over the y equals x axis, okay, so that's going to be a little tricky, but it is doable. Okay, just one of the points isn't going to move very much. Okay, so if we line this up right, okay, there we go. So if we reflect it, here is our pre-image. A, B, and C. Again, we have 2, 1, 5, 2, and 4, 4. And we have image 1. Okay. And so we are going to get A prime, B prime, and C prime after our reflection. So we're going to flip these guys around. So we're going to get 1, 2. B is going to then be 2, 5. And C is going to be 4, 4. 4, 4 didn't change. It was sitting on the line. Okay, so we obviously are going to share a point there. So I'm going to encase that in red underneath. We're obviously going to be, and this is a 1, I apologize. Okay, so we're going to go over 1 up to 1, 2. And I'm going to actually clean that up and redo it. There we go. So there we go. And then over 2 up 5. So over 2 up 5. 1, 2, 3, 4, 5. There we go. So, and then if we go ahead and connect the points. There we go. C prime, B prime, and A prime. You can already see something is not right. We are not in the same position as our first step here. Now we're going to rotate this thing 270 degrees. I'll have to put this down here because I don't have space to squeeze them in here. So then image 2. Okay, A prime is going to then, we're going to see here. So 270 degrees we're going to do here, which means we're going to flip these around again. All right, so we're going to go back and we're going to make these 2, -1, 5, -2, and 4, -4. Okay, so let's see here. So we've got 1, 2, 3, 4, 1, 2, 3, 4. Okay, and then we've got over 2, down 1, 1, 2, down 1. There we go. Okay. And then we've got over 5, 1, 2, 3. So 1, 2, 3, 4, 5, down 2. Okay, there you go. And then if we connect all the points, So we've got A double prime, C double prime, and B double prime. And again, remember that this, now what's funny about this is that if you look, this essentially right here is a direct reflection over the x-axis, but we're not doing that. So be careful. Some of these can confuse you and they can mess you up if you're not paying attention. Okay, so, but we are looking specifically at this rotation. So again, if I check for my little right angle in here, yep, there he is. Nice, pretty right angle. And then that means that this right here is 270 degrees and it checks out, but they are not the same thing. So, all right, the order does matter, all right? Keep that in mind, especially going forward. Now in class, I believe we talked about this at the end, but I want to just be blunt here because this is recording and it's supposed to be more surmised up. So that will be very important that you understand that. So I guess in the bottom, I could state the following, okay? In conclusion, the order at which transformations occur in a composite transformation does matter. Depending on which comes first, it will significantly impact the orientation of the shape upon completion. And that orientation is messy. I'm going to rewrite that. But I think you guys get the idea. Okay? It'll significantly impact the orientation. So, however, there is one specific kind of transformation we do need to talk about. All right? And then a quick summarization of all of this information. And then that's it. And then you guys have reached the end of the whole unit on transformations. Congratulations. Okay, so we need to talk about really quickly a particular type of transformation called a glide reflection. Okay? He's important. Okay? And just for all you English buffs out there, yes, this is a noun. Okay? Glide reflection is a transformation consisting of a translation combined with a reflection. About a plane parallel to the direction of translation. Okay? So what does that exactly mean? Let's say, for example, here we go. Here's what I got. Okay? So let's say I have, just a normal triangle, nothing crazy. And we only need to really worry about the x-axis here, but I will put the y-axis over here on the side just so we have it for connotation, if you will. Okay, so let's say I have a shape that looks like this. Okay, and I'm going to reflect it across the x-axis. So I'm going to go here with it. 1, 2, 3, 4. 1, 2, 3, 4. There we go. Okay, so he reflects across the x-axis. Okay, so he goes this way, and then we just push him that way a little bit. Okay, nothing too crazy. Okay, so there he is. And that's all it is. That is literally it. Now, an interesting question to ask here, however, is does the order matter here? Well, technically, on this version, it doesn't. And here's why. If I shifted him and reflected him, I would have gotten to the same location. Would I have not? I would have. So a little star I would put underneath this. Okay? Unlike many other composite transformations, the order at which the reflection and translation happen do not matter. It is what we like to refer to in mathematics as a special case. Okay? So, in conclusion, just to wrap things up, all right, a couple things that I would keep in mind and make some very important note of. I would highlight these if you can. Is just a quick summation of everything. Okay? Composition, sorry, now we're going to break out the shin. Composition of transformation. When two or more transformations are combined to form a single transformation, right? The other term we introduced was glide, or glide reflection. Which is a translation followed by a reflection. Again, the order doesn't matter, so I could have said reflection followed by a translation. Now, the final thing we need to talk about is notation. Okay, this is the first time you're going to see this word and the first time you're going to be using what it means. When I say the word notation, okay, what I'm referring to are the symbols for compositions in an open circle. Basically meaning this is notation refers to mathematics as the language of mathematics. Okay, that's basically what it means. In this example, what we're going to talk about specifically is the symbol for composition is an open circle. Okay, so that's what it means. The symbol for a composition, meaning I want to say there's a composition, is an open circle. Okay, so let's say, for example, I'm going to reflect over the x-axis with a composition of the translation 3, 4. Okay, so what is that actually saying? Okay, well, this is what it means. And you need to be careful. Okay, this means a reflection in the x-axis following a translation of right 3 and up 4, aka x plus 3, y plus 4. And that's it. Congratulations, you finished all of the sections on translations. If you have any questions for me, feel free to ask or email me. I know this was a very long section, being especially the fact that we covered about 30 minutes worth of content, but that was because there was a lot here to take in. I'll probably split this video into 2 parts.